Have you ever wondered about the beginning of time? How the first stars, galaxies and planets formed? Do you think about our place in the cosmos and how we came to be here? Do you wonder if there is anybody else out there? And if they enjoy football as much as we do? To answer these questions, scientists and engineers build telescopes to help us see back in time. I'm one of them, and I'm playing a small part in the creation of the most powerful telescope ever built, the Square Kilometre Array, or SKA. The telescope will be a bit like the compound eye of an insect. Radio signals from hundreds of antennas will be combined to simulate a single giant telescope capable of producing images of incredible sensitivity and resolution. And they will show us what was happening a long time ago in galaxies far, far away. But building a telescope on this scale throws up a lot of challenges. The challenge that has been the focus of my research is how to transmit really precise signals throughout the telescope network. Radio telescopes need each of their antennas to be synchronized to the ticking of an atomic clock at the heart of the array. The time signals travel through fibre optic arteries out to the antennas, but the SKA will be so vast that the signals will become too degraded for the telescope to work. The system I've built works by bouncing part of the signal back from the antennas to the atomic clock. An electronic system compares the returning degraded signal with how it should look, so the way the signal has been disturbed can be measured, and the next tick or tock will be corrected to allow for whatever is causing noise on each line. I've been progressively improving the system and making it more reliable. In South Africa last year, I demonstrated that it could stabilise signals sent over cables strung from telephone poles and swinging in the wind. This means the cables won't have to be buried, and not burying them will save the project millions of dollars. In June this year, I tested a prototype on a radio telescope in New South Wales. The prototype was so successful, we know it will transmit signals across the array with a stability of 1 part in 10 trillion. That's like noticing 1 grain of sand is missing from an entire beach. Even better, the production prototypes are so small, they can be placed right next to the receiver in the telescope, which is an important advantage over much bigger systems designed elsewhere in the world. It also makes them better suited for industrial applications outside of radio astronomy. This signal stabilisation system will allow the SKA to deliver the most stunning images of the deep universe, the best we've ever seen. It will help us to understand our place in the cosmos, and perhaps help us find out if there is anybody else out there. Thank you.